In this video, we're going to look at numerical concept 2, which is also known as SADS. Now, what do we know? What do you know about SADS? When you talk of SADS, we mean the numbers which are not having exact root. In other words, we call them irrational numbers. Numbers that cannot be expressed as fractions. Numbers that cannot be expressed as ratios. When you look at example of numbers that can be expressed as ratios or numbers which we call the rational numbers. The common examples which you're having here, some few examples you're having 5, 2 and a third, 0.37, square root of 49. These numbers here can be written as fractions. 5 as a fraction is 5 over 1, 2 and a third, which is a mixed fraction, as an improper fraction is 7 over 3. 0.37 is 37 over 100. And when you look at the square root of 49, of course, is a plus or a minus 7 over 1. So these numbers are not SADS. However, numbers which are called SADS are those which cannot be expressed as fractions. For example, we are having pi, whose value is 3.14159, and so on. The square root of 3, when you look at the square root of 3, cannot be expressed as fraction. The square root of 2, square root of 7, square root of 13. In other words, the square root of numbers which are not square numbers are the ones which are called the SADS. Now, when you talk of SADS, SADS are of two types. We have the like SADS and the unlike SADS. How do you know that a given SAD or given SADs are like? Now, those two or more SADs are like if they have the same irrational factors or if the numbers under the square root are the same. For example, if I have 3 root of 2 and root of 2. In the first SAD, I'm having root of 2. The second, I'm also having root of 2. So the numbers under the root here are 2 and 2. So these two SADs are like. Another example can be 2 root of 5 and 3 root of 5. Also here, the numbers under the root here are the same. Therefore, these two SADs are like. Now, for two SADs to be called unlike SADs, then they must be having different irrational factors. They must be having different irrational factors. Example of unlike SAD can be if I'm having 4 root of 5 and 2 root of 3. Here the numbers under the square root signs are different. Therefore, these two SADs here are called unlike SADs. Now, for you to be able to answer questions on SADs or the rational numbers very well, you have to be well versed with the rules of SAD. So let me take you through the rules of SADs. Rules of SAD. Rules of SADs. Now, the following are the key rules that you need to follow when you're dealing with questions under SADs. We take an for example, if A, B, and C are whole numbers, then Roman number 1, root of A times root of A. This is going to give us root of A squared, or which root of A squared is just A. So root of A times root of A is giving us just A. The next one is A times root of B. Now this A will multiply the coefficient of the root, which is going to be A root of B. This is the second rule. The third one can be root of A times root of B. This is going to be root of, then the A will multiply the B, which is A times B, which is the root of AB. The fourth one can be A over root of B. Now here, what do? I multiply both the numerator and the denominator by the the denominator, which is a times root of b over root of b times root of b, which is going to give us a root of b as per the second rule here, over root of b times root of b as per the first rule there is giving us b. So it's over b. The fifth rule can be, if I have root of a over b, this can be root of a over root of b. Finally, the sixth one can be, if I'm having a over root of a plus root of b. The same applies here. I get the conjugate of the denominator. This, then I use the conjugate to multiply both the numerator and the denominator. This will be a into root of a minus root of b. Of course, if in between the two roots here, the sign here is positive, then the conjugate will bear an opposite sign. Now this will be over root of a plus root of b. I multiply the numerator and the denominator by the conjugate over root of, times root of a minus root of b. And this is going to give us a into root of a minus root of b over, of course, when you simplify this, you realize that this is a more of a, what do I mean by this statement here? Now here, for me to get this figure here, this whole number here, that means I have to take each and every value in the first bracket to multiply each and every value in the second bracket. In other words, I have to expand these two different brackets here. So I will take this root of a to multiply each and every entity in the second bracket. So root of a by root of a is going to give me, of course, a. Root of a times negative root of b will give me negative root of ab. Now, what do I mean by this? I'm saying that this is the same as a into root of a minus root of b over, then I take this first entity to multiply each and every value in the second bracket. This will be root of a into root of a minus root of b. I also bring this with the sign plus root of b into root of a minus root of b. Then this is now equaling to a into root of a minus root of b over root of a times root of a. Here we get that is a as per the rule. Then root of a times negative root of b, we get negative root of ab. Also positive root of b times positive root of a, we get plus root of ab or ba. Then positive root of b times negative root of b, we get minus b as per the rule. So these two will cancel, giving us back that very statement. Thank you for being with me throughout the lesson. Let's meet again next time when we shall be handling simplification of surds and addition and subtraction of surd. Thank you. Don't forget to subscribe to our channel, GVN Academy, and turn on the notification button so that you get updated with every post of ours. Thank you.